Welcome, 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 everybody. It is Thursday of Albert's Weather Classroom, Thunder Thursday, when we talk all about severe weather today. As we start off every Albert's Weather Classroom, it's time for a roll call. Where are you watching from? What grade are you in? I want to hear from you. And we've got some great friends that have been tuning in all week. Let me show you here on the big screen. Hi, everybody. Hope everyone's having a good morning so far. Look at some of our new friends that have been watching Albert's Weather Classroom. If you've missed the first 3 days, no problem. They're saved on YouTube for you. The links are posted there on the YouTube page as well as on my Facebook page. But our friends have been watching, eating lunch, learning about Freddie the Frogcaster yesterday. On Tuesday, we talked about the atmosphere. On Monday, it was our introduction to weather. I want to leave out our friends watching Freddie Frogcaster yesterday. Also, some more friends watching Monday's lesson, Introduction to Meteorology, and it looks like we're watching yesterday's lesson, Tuesday's lesson actually, right there. So send me your pictures, parents, big brother, big sister, aunt, uncle. KVUE Albert will share some pictures tonight on the 10 o'clock news like we have the last couple of nights, and we'll kick off our roll call where everybody's watching from when we start off tomorrow when we talk about weather forecasting. But today, this is my favorite presentation so far. This is going to be a little bit longer than the last couple of ones, but I think you're really going to enjoy it. I'm calling it Thunder Thursday because we're talking about thunderstorms. We're talking about severe weather. I'm going to show you how tornadoes form. I'm going to show you how hailstones form. I'm going to show you how lightning forms. We're going to talk about flooding, and I've got a lot of cool videos to get to you as well. So we've got a really fun day ahead. So we've got folks from Georgia watching. Ashley's got a 1st and 5th grader watching. Sarah is ready, set, go. Let's do it. We've got Luke, a 2nd grader from Austin. So welcome everybody, and let's get started. First, a shout out to my friends at the National Weather Service here locally at the New Braunfels office. They put together a great program every spring called Skywarn. If you're really interested in meteorology, I encourage you to check those out. Of course, we're not doing any in-person this spring, but they're doing some online classes, and some of the videos that I'll show today are courtesy of them. So, an overview of what we're going to talk about. We're going to talk about these guys. Remember on Tuesday when we talked about the atmosphere and we talked about clouds? What is this kind of a cloud called? Cumulonimbus cloud, a thunderstorm. And we like thunderstorms. We need the rain, but sometimes when the ingredients in the atmosphere are just right, thunderstorms can turn strong or severe. So we'll talk about lightning associated with thunderstorms. We'll talk about hail associated with thunderstorms, how that forms. And then towards the end of the program, we'll talk about tornadoes, and I've got some interesting video to show you. So let's start off with the basic thunderstorm. This is a picture. Looks like an explosion in the atmosphere, doesn't it? This is not from far away. If you're here in the Austin area, this was taken a few years back up around Round Rock, and this was an interesting day. All day long, morning till about 3 or 4 o'clock in the afternoon, deep blue skies, sunshine, and then boom, an explosion in the atmosphere. This cumulonimbus cloud developed, going tens of thousands of feet up. Here's another photo of a developing thunderstorm. And just to give you an idea how high these guys can go, if you look closely, kind of this real thin line, see that right there? That's actually a commercial airline going by. So the cruising altitude for American Airlines or United or Spirit is about 30 to 35,000 feet. These thunderstorms can go 50, 55, even 60,000 feet. They go way up there depending on how strong they are. This is just a quick diagram of what's going on inside a thunderstorm. And we won't get too much into this just yet, but the theme today is going to be this. Inside thunderstorms, you have air going up and you have air coming down. We call that updrafts and downdrafts. Air going up, air going down. And that is the theme today for really the development of everything that we're going to talk about. This updraft and downdraft business is a big reason why we have tornadoes and the development of hailstones and the development of lightning. So remember that air goes up and air goes down within a thunderstorm. Now let's just talk about the basics of a regular thunderstorm, not necessarily a severe storm, just the basics of a thunderstorm. Here are the ingredients that you need. First things first is you need moisture. What is moisture? You know, even this morning, if you stepped outside, it felt a little stickier than the last couple of mornings, like it just feels humid, or some mornings you walk outside and like within minutes you just start to sweat because it's muggy. We call that humidity. So that's moisture in the atmosphere, what we call water vapor. Think of it as invisible water. Moisture is the key ingredient. You've got to have that. If you don't have moisture, you're not going to get even rain. The next ingredient on the list, I should say, is going to be instability. What is instability? Instability is the natural rising motion in the atmosphere. These little parcels of air, right? Just to allow them to float upward. That's just natural instability. What can kind of cause instability is a really hot day. What does hot air do? What does a hot air balloon do? Does it sit on the ground? No, it goes up, right? The hot air balloon goes up. So we know hot air rises, and that can allow for some natural instability in our atmosphere. And the third ingredient to the list is going to be lift. Now, in meteorology class, if you go to college, we'll call this a triggering mechanism. It's like, what? This is the best way I like to describe it, even on TV. So you've got gasoline, right? We've got our engine, but you got to have a key to put it in the ignition and turn it on, right? So gasoline, moisture, the engine, the instability in the atmosphere. The lift is that ignition, something to turn the thunderstorms on. Lift allows for even more upward motion in the atmosphere. And lift can be anything from a cold front, which separates cold air from warm air. It can be a warm front, which separates cool air from warm air. It could be what we call a dry line. We'll see those within the next couple of weeks. Dry line separates dry air from humid air. So then there's those three ingredients. This is just for a normal, everyday shower or thunderstorm: moisture, instability, and lift. Now, what about severe weather? And that's kind of what we get into now. You have to have one extra ingredient to have severe weather. Looks like that started from the beginning. Hang on. So there we go. Wind shear is the fourth ingredient that you need. What is wind shear? Wind shear, there's two different types, but this separates an average, everyday, what I like to say, garden variety, no big deal thunderstorm from a real deal, strong if not severe thunderstorm. So wind shear is what's going on in the atmosphere when it comes to wind. And there's two different kinds of wind shear that we talk about. There is wind shear, what we call speed shear, where the wind will increase or the winds will go up as we go up in height. So here's an example. Let's say this is where we're standing, right? We're on the ground. We've got a nice breeze coming in from this direction, and it's maybe like 10 miles per hour. But then we're back in our hot air balloon. We're always in that hot air balloon. We go up a little bit higher, and now it's 20 miles per hour. And we go a little bit higher, now it's 60 miles per hour. And we go a little bit higher, it's 80 miles per hour. So this increasing wind speed as you go up in the atmosphere is a type of wind shear. And this is important for severe weather because a normal thunderstorm will just build like that, right? It'll kind of last for a little bit and then it'll fall apart. But wind shear allows for the thunderstorms to build and then start to tilt. And a tilting thunderstorm separates that air going up and that air going down. Updrafts and downdrafts. And that allows for thunderstorms to just last longer and to also get stronger. So that's one kind of wind shear. That's for severe weather development. The other type of wind shear is wind coming in from different directions at different heights. So let me explain what that is. And I keep hitting that button. Let me just go towards the very end here and we'll let this play out. So again, we've got wind coming in from this direction, right? We get in our hot air balloon, we go a little bit higher in the atmosphere. Now the wind is coming from the opposite direction. So you have crisscrossing winds at different levels of the atmosphere. And that crisscrossing of winds allows for this: rotation, horizontal rotation. Now, do tornadoes spin like this? No, they spin like this, right? So how does it go from this to this? We'll cover that in a couple of minutes when we talk about tornado development. But that's the key ingredient. So moisture, instability, lift for a garden variety thunderstorm. What's that fourth ingredient to have severe weather? Wind shear. That's the next one. Okay, so let's go to the next slide here. Let's talk about the definition of a severe storm. Now, you've heard a severe thunderstorm warning is in effect, or a tornado warning is in effect, and you'll see it if you're watching KVUE at the bottom of the screen. So this is what separates a normal thunderstorm, because not all storms are severe, a normal thunderstorm to a severe storm. This is the criteria from our friends at the National Weather Service, the ones that issue these warnings. When it comes to hail, it has to be the size, these little hailstones have to be the size of about a quarter. About 1 inch diameter or larger. Damaging winds, Doppler radar, what we use to find out where the rain is falling and how heavy it's falling, can also give us an idea of how strong the winds are within thunderstorms. So winds have to be 58 miles per hour or higher to consider it severe. And then of course, if you have evidence on radar that there's enough rotation that a tornado could be developing, or you have information from law enforcement or storm chasers that are tornadoes on the ground that will issue a warning as well. So what's missing? We've got hail, we've got tornadoes, we've got damaging winds. What other kind of weather phenomenon is missing from this list? That explosion that we hear. We talked about that back on Monday. What's that explosion we hear when we see the bright flashing light? Thunder, right? So notice lightning is not included in this. So just because you could have the most electric thunderstorm ever, they won't issue a warning. Lightning is certainly dangerous. 50,000 degrees Fahrenheit, 5 times hotter than the surface of the sun, but it will not trigger a warning. So here's a look at video. We'll try to see if we can play that again. This happened last spring of lightning hitting behind the Frost Bank Tower. We were able to capture that with our KVUE downtown camera. We'll watch that one more time. Look at that. So there's a couple of different lightning that we look at. What we call cloud to cloud or intra-cloud lightning, or this one, cloud to ground lightning. So we're going to get into lightning right now, and then we'll get back into severe weather as well. But I did want to mention that you could have the most impressive lightning storm on the face of the earth, but you're not going to get a warning out of it. We often get times in the Weather Center where it's like, man, the lightning and the thunder is crazy. Why aren't you guys on TV? Why aren't you issuing warnings and stuff like that? It's like, well, lightning doesn't meet the criteria. So I talked back on Monday how I really got interested in meteorology and weather when I was a second grader. So think about this. I've been thinking about weather and meteorology for over 30 years, literally every day of my life. And when I was young, I was probably junior high. I grew up out in the country, out in South Texas in a community called Beeville. And one of my hobbies was photography. I don't do this so much anymore because I'm working usually when we have bad weather. But these are some of the photos I was able to take. I was in a safe spot, but this is a look at cloud to ground lightning. Okay, there's one photo. Here's another one. This one won a prize on a 4-H photography competition when I was in junior high. I may have even been middle school or something like that. My parents were really good parents, but they let me take pictures of lightning. That aside, so we also have cloud to cloud lightning, or what we call intra-cloud lightning, where it doesn't connect to the ground. It goes from cloud to cloud. Here's another shot. Again, these are all photos I took as a young person, and they hold up, and I like to still show them on my presentations for schools. This is video sent in from a viewer last spring, and it's a slowed down version of intra-cloud lightning. Look at that. It's just super impressive. Lightning bolts that come in with this stuff. Let's watch it one more time. There you see it connecting from one cloud to the other. Go to the next slide here. So how does this all come together? We'll talk about how intra-cloud or cloud-to-cloud lightning develops, and we'll also talk about cloud-to-ground lightning. But there's also different charges with lightning bolts, positive and negative charges, and we'll talk about that as well. But we're able to use technology, and we can actually tell on our display at work what kind of charge a lightning bolt would be, whether it's positive or negative. And there's a big difference between the two. One's a lot more powerful than the other. So remember the theme today. It's all about updrafts and downdrafts, right? Everything we talk about today is going to be about that. So you have air rising up and air rising down. Now, as the air rises up within a thunderstorm, it's going to eventually reach a level of the thunderstorm where the temperature is 32 degrees or lower. And what's that? What's 32 degrees Fahrenheit? It's freezing. So it could be the hottest day in August. If you get a thunderstorm, these little raindrops will eventually make their way into an area, what we call the freezing area of the thunderstorm. So what you have going on in the thunderstorm are little pieces of ice and even hailstones and sometimes water droplets kind of rubbing together. Here's the best way to think about it. You know, maybe at your house or at a store or at school, maybe at the library, and you're walking around, right? You're just kind of, this is how I walk. I walk like this. You're walking around and then you touch your friend or a doorknob, and what do you sometimes get? You get a little static electricity, right? So what you're doing is, as you're walking around like this, you're creating a charge in your body, right? You get this charge going, and then when you connect to a different kind of charge, whether it be a doorknob or your friend, you'll get that little static electricity shock. So instead of shuffling feet, we've got the same thing going on in the clouds. We've got shuffling pieces of ice rubbing together to create a charge in the cloud. So what happens then is you get these different charges at different parts of the thunderstorm. So to kind of get your bearings straight, there's my house. That's my beautiful tree that has a lot of oak pollen right now. So we've got different charges. We'll call it positive charges down here. And then with that shuffling of ice in the cloud, you'll get a separation of positive and negative charges, kind of like a battery. Think of it like a battery, positive and negative charges. And when everything gets just right, these positive and negative charges will connect to each other. So inside the cloud, you can call that intra-cloud lightning or cloud-to-cloud lightning. And then, let's play this. You'll get also cloud-to-ground lightning coming in from the cloud and connecting to the ground. So positive, negative, intra-cloud lightning or cloud-to-cloud, negative, positive to the ground. You get what we call negative cloud-to-ground lightning. So we talked about there's also different charges of lightning. You'll get this negative lightning from the cloud, kind of middle part of the cloud to the ground, but then you get these huge thunderbolts, what we call positive cloud-to-ground lightning. Let me go back to the end of that. So what's happening with these positive cloud-to-ground lightning, these are really impressive, really, really powerful. They're coming in from the anvil or the very top of the thunderstorm. Remember how we just talked about how thunderstorms can be 50, 55, 60,000 feet? So these originate from the anvil, from the very top of the thunderstorm, and they go all the way to the ground. So they have to be super, super powerful to make it all the way to the ground. That's why positive cloud-to-ground lightning strikes are super, super dangerous. And most house fires and really most injuries are going to come from these guys. So positive lightning strikes, the ones that come from the anvil and connect to the ground, only account to about 5% of lightning, of all lightning you see. So it's rare. Unfortunately, I've noticed though, whenever we get big storms here in Central Texas, we get a lot of these more and more recently. The flash duration, or what you see when it strikes and then it kind of does one of those things, is longer because it's a much more powerful bolt than your ordinary negative lightning strike. It is 10 times more powerful than the negative charge lightning. The ones that are coming from the anvil are 10 times more powerful because they've got to go to the top of the cloud all the way to the ground. As much as 1 billion volts. Super, super powerful. And here's the one thing I want everyone to remember is that these can strike 25 miles away from a storm. We had an incident that happened several years ago. We had a thunderstorm probably about 15 miles away, and it was kind of like that one storm I just showed you that was in Round Rock. Blue skies, and it just kind of developed. And there's soccer practice going on, or a soccer game going on, and 15 plus miles away, a lightning bolt hits somebody and hurts that person. So, as we talked about back on Monday, when the thunder roars, go indoors. This is why we say that. Because even though it could be blue skies and sunshine on top of you, if you can hear thunder in the distance, you're close enough to be struck by lightning. So when the thunder roars, go indoors, and it's because these are powerful lightning bolts that we track. And most of the time when we talk about house fires due to lightning, it's because of these positive lightning strikes. Okay, let's get into hail. Hail is these big chunks of ice that can come out of the cloud. And here's some video of hailstones coming in. It's a little jerky, but you can see the powerful hailstones hitting that swimming pool. Look at all that, kind of covering the ground. So hail, if it's the size of a quarter or 1 inch in diameter or larger, it's considered severe. Here's some different sizes. Now, oftentimes we'll get this little stuff, right? So see, some of them look like the size of maybe a dime to a nickel. That's below severe weather limits. It certainly would hurt if you get hit in the head. That's why you got to be inside during thunderstorms. And then you see this one, maybe the size of a quarter or $50. That's severe. They can get really big, the size of an orange, the size even bigger than that. I mean, a grapefruit size hail. That can certainly happen even here in Texas. And then depending on what's going on within the thunderstorm, when it comes to melting and then adding additional layers to ice, you can get some interesting looking hailstones like this spiky one. Look at this one, as big as a $20 bill. And then it can do just a tremendous amount of damage. We saw this happen a few years back in San Antonio. Big hailstones coming in and doing just a tremendous amount of damage to vehicles and to homes and stuff like that. And we saw that here in Austin as well. So this is just a quick diagram that I'm going to show you an animation of what's going on within a thunderstorm. So going back to our theme, updrafts and downdrafts, if you have a strong wind going up within a thunderstorm, it can take a little raindrop, a normal raindrop that comes out of the sky, and it can carry it way up in the thunderstorm. And the higher you go, what happens? What does the temperature do? The higher you go, it gets colder, right? So that raindrop eventually makes its way into the freezing level of the thunderstorm, and then it freezes into a piece of ice. Then the downdraft, that wind brings it back down, and then it goes right back up. So it gains another layer, another layer, another layer, another layer, until it's so heavy that the storm can't hold it anymore, and it drops. So the updraft, or that upward wind in the atmosphere, is the big decider on how big hailstorms are going to be. So here's an animation of how hail forms. And here we go again, back to what we were talking about, updrafts and downdrafts. That updraft in the atmosphere, very, very important for us to know how large the hail is going to be. So a strong thunderstorm that is producing, damaging winds, and it's rotating, and it's got just a tremendous amount of force going upward, is a severe storm. So you'll notice our hailstone here, and then watch as it continues to go up and down, up and down. It'll get bigger and bigger and bigger until it's so heavy that it eventually falls. And if you have a thunderstorm that's producing pea-sized hail, or maybe the size of dimes, it's a fairly weak thunderstorm. Whereas if you have a thunderstorm producing tennis ball, baseball, grapefruit-sized hail, that is a very, very powerful thunderstorm that has a very powerful updraft in it. So again, we'll look at this one more time. There you see the updraft and the downdraft in the thunderstorm. You get this kind of rotation of the hailstone going up and down, all starting off as a rain droplet, then freezing, and then getting bigger and bigger and bigger until it's so heavy, could be the size, again, baseball plus, until it falls to the ground. So that's how hailstones develop. So here's some different types of the sizes that we can see. The National Weather Service, they like to get reports, as we do too, at least on these smaller ones when it comes to money. So we don't like to say pea-size hail, because there could be different sizes of peas, right? So we like to say, oh, it's penny size or quarter size. Anything quarter or larger is considered severe. This is a $50. So we'll get golf ball size hail. We can get, look at this, pool ball size hail, which is 2-inch diameter. 2 3/4 inch diameter is baseball size hail, and occasionally softball size hail. Just big, big hailstones coming in. That's 4.5-inch diameter hail, and that can certainly happen. Okay, we talked about lightning. We talked about the thunderstorm development, the ingredients we need. We talked about hailstones. Now we're going to talk about flooding. So flooding is a type of severe weather. It gets its own kind of a warning. We call it a flash flood warning or a flood warning. This is video that was taken 2 Octobers ago, when we had all the flooding in the hill country along the Llano River. If you're from this area, you may remember we had just awful flooding along the Llano River that made its way all the way into Lake Travis. This was the precursor to that, or this is what happened before that big event. And my friend Marissa sent this video in. This is in Mason County on Highway 87, and we'll watch this for a few minutes, but you'll see how things are pretty calm here, and then watch the water start to really come in. So this is flood water. What's happening is you had a lot of rainfall in a short period of time falling upstream, or falling, farther away from this location. So it doesn't necessarily even have to be raining here. All that flood water, all that rain that came down in a short period of time, is now making its way through this particular river, which is the Llano River. You can see an old bridge here. You can kind of see some pilings, some concrete pilings right there. That's an old bridge that was washed out many, many years ago because of a flood like that. So they built this much higher one, and this is where this video is being taken, in a much higher, much more sturdier looking bridge. So I'm just going to kind of go towards the end a little bit so you can see just how ferocious the floodwaters are. And along with the dirty water, you get all this debris, so branches and leaves, and you'll get ant piles and this stuff. So the reason we talk about flooding a lot is because where we live here in Central Texas, if you're watching us from Central Texas, this is our #1 issue when it comes to severe weather. It's flash flooding. It's flooding that can really impact our city and our communities for creeks and rivers and whatnot. So this is video from that same week, or about a week later. And some of you may have seen this on, I apologize if this is real jerky looking, but there you go. Actually, let me back this up. I'm giving it away. So basically what happened here is, this goes back to what we talk about turning around, don't drown. And this is a school bus driver who no longer has his job because he saw this flooded roadway and said, oh, I can make it, and watch what happens to him. There are kids on board. There's a few kids on board, and that's why this guy not only is no longer a bus driver, but he got arrested as well, because you can't do this, especially with other children in your possession. So even a big school bus, which is super, super heavy and it's got big tires, it was still carried off this flooded roadway and carried downstream. Everybody's fine. Nobody was hurt. They were rescued and everything's good. But as we said back on Monday, turn around, don't drown. You don't know how deep the water is or how fast the water is moving that could really impact you, whether you're in a small vehicle or like that, a big bus. So we're going to go from flooding now to tornadoes. I know a lot of you have been waiting on that. This is an old video from KVUE. So this is what we call a countdown clock. That's one of our friendly bats that lives under the Congress Avenue Bridge, our old KVUE logo. This is going to be video from 1997. Our photojournalist, Scott Guest, who still works with us, just saw Scott a couple of weeks ago. He was a photojournalist on May 27th, 1997. And the meteorologist at the time at KVUE said, hey, you need to go north of Austin, go towards the community of Prairie Dale and Gerald, kind of in northern Williamson County, southern Bell County. We've got some storms coming out of Waco that have had the history of producing tornadoes. So he got there, and this is kind of in the Prairie Dale area, and here's the tornado developing. It's a fairly weak tornado at this point. You can see it's kicking up some dust and some grass, but there you see the debris right in here. And this is the tornado. Look at that, kind of unwinding a hay bale a bit. But over the next several minutes, this went from a relatively weak tornado, almost looks like a dust devil, right? Just a very powerful dust devil. Went from something like this to a 3/4 mile wide monster with over 200 mile per hour winds, and eventually went through the community of Gerald, at least the subdivision of Gerald. So I'm going to fast forward this so you can see how over just a few minutes, how it became even more powerful. This is just raw footage that he took on his camera that we have in our archives. But notice how much more powerful it is right now. And there's debris that's spinning around the tornado right in there. So we'll go a little bit farther into the video and notice how much larger it is now. This is when it's 3/4 mile wide, and this is when it's going over a subdivision or where people were living. And back on Monday, I showed you some pictures that I took when I was a 7th grader of the damage of this tornado, and it's devastating. So, but going back to what we talked about on Monday, yes, tornadoes can happen where we live, but they don't happen often. And just like when we do fire drills at school or we do severe weather drills at school, doesn't mean a fire is going to happen or bad weather is going to happen while we're at school. But why do we do it? To be prepared. And us being at home for the next few weeks is a good opportunity for the family to get together and just to be prepared like we do at school. Where would we go just in case if bad weather happens, right? I think it'd be a good family project the next couple of weeks. And bottom line is you want to find an area of your home, lowest floor. If you live in a 2-story home, it's got to be the first floor, and it's got to be a room that doesn't have windows, preferably in the center of the house. For me, it's a bathroom, doesn't have any windows, center of the home. And for some of you, it may be a pantry, maybe under stairs, maybe a bathroom like mine, as long as it doesn't have windows like that. So again, we don't do it to like scare you, but once you're prepared and you know where to go, just in case some bad weather does happen, there's no reason to be scared. You know, I'm going to take my tablet, I'm going to take my phone, I'm going to go to our safe spot, and as long as we're there, we're going to be A-okay. So that's the way you got to look at severe weather. Here's a look at the tornado video from 2011. This is in Tuscaloosa, Alabama. That part of the country, Alabama, Mississippi, Tennessee, North Texas into Oklahoma and Kansas, a little bit more to the north and northeast of us, is a lot more of an area that sees severe weather than we do here in central Texas. So they certainly can happen here, but usually they're pretty weak and short-lived. And as long as you're in your bathroom and again away from windows, you're going to be A-okay. So as we talked about on Monday, we're going to have some rain and some rumbles of thunder. maybe a little bit tomorrow night, and then we'll have a little bit more on Monday. Just because it rains and just because you hear thunder doesn't mean it's going to be severe weather. So I don't want you to have this kind of scared anxiety like, oh no, it's thundering outside. We get thunder. We like rain. We like for rain to grow flowers and to grow our vegetables in our garden and stuff. My job as a meteorologist, and my other colleagues here in our community that are meteorologists, or if you're not watching from Austin, the ones that live in your area, it's our job to give you a heads up days ahead of time, and hopefully even longer than that bad weather could be coming. That way you can put your action plan into motion. So again, just because you hear thunder or it's heavy rain doesn't mean it's bad weather. Nothing to be scared about. Have a plan with your family and know where you would go just in case it happens, just like you do at school. So let's get back into the science of our tornadoes, how they form, right? I know a lot of you are probably asking just that. So back to that fourth ingredient on how a thunderstorm can turn severe. Normal thunderstorm, no big deal, right? Moisture, instability, and lift. Moisture, water vapor, instability, rising motion in the atmosphere, lift, the key in the ignition, and you're turning it on. You turn on the storms to get going. The fourth ingredient for severe weather is, again, wind shear. And this crisscrossing of winds for wind shear, what we call directional wind shear, is important for the development of tornadoes. So here we've got winds coming in from one direction, and then as we go higher up in the atmosphere, you have winds coming in from a different direction. So you have this crisscrossing of winds. That allows for this rotation in the atmosphere, this horizontal rotation in the atmosphere, right? Just because you have the crisscrossing of winds. There you go. So remember we talked about inside a thunderstorm that you will have updrafts, air going up in a thunderstorm. So the strong air going up within a thunderstorm will take that horizontal rotation like this and then begin to make it more vertical. Does that make sense? So we're rotating like this, rotating like this. You put a thunderstorm that has this motion upward, and now you start to have this kind of rotation. So this kind of rotation, this vertical rotation, allows for the whole storm to just spin. And a spinning storm is a mean storm. Doesn't necessarily mean it's going to produce a tornado, but it certainly can if all the ingredients are in place. So as you have this spinning thunderstorm, towards portions of the storm, you can get what's called a wall cloud or a low cloud hanging. That's spinning. That's kind of the precursor or something that happens before a funnel cloud. A funnel cloud looks like this, but not touching the ground, right? And then once it has ground contact and it starts to spin up that debris like we saw in that video, then it's considered a tornado. So it's all about the crisscrossing winds of the atmosphere, rotation like this, strong updraft. The same updraft that can make big hailstones then makes it more vertical, and that can allow for the tornado to develop. So that's the science behind a tornado. Okay, so we talked a little bit about this on Monday, but if you look at a tornado like we saw in that video, you could tell, that looks like a weak tornado, or that looks like a really mean tornado. But you can't say that is a EF1, an EF5. What's EF? So EF stands for Enhanced Fujita Scale. This is the scale that meteorologists use after a tornado passes to find out how strong the tornado was. Weather equipment, like an anemometer, is not going to survive a 200 mile per hour wind, right? So you can't have a direct reading from it. But we know from science and we know from meteorology and also physics how strong winds have to be to peel a roof off or to break parts of a home like a 2x4 and stuff like that. So that's where the Fujita scale comes into play. So most of the tornadoes that we get here in Central Texas are on this 0 scale. It goes from 0 to 5, and we're usually 0 to 1. So we're talking about winds 80 to 100 miles per hour, enough to peel some shingles or those little square things on top of your roof, bring down some tree limbs. That's the majority ones that we see where we live here in Central Texas. That's why, again, if you're in that safe spot in your home that doesn't have windows, you're going to be fine. And the reason why we tell people to stay away from windows is because a 90 mile per hour wind can bring down a tree branch, and I've got a tree right here, my window's right here, and if that tree branch hits my window, what is it going to do? It's going to break the glass and may cut you up. That's the only reason why we say stay away from windows. Then you get into a little bit more strong tornadoes. EF2, EF3 can just do a tremendous amount of damage. I mean, this is, as long as you're in a safe spot though, in the center of your home, you're going to be okay, but just a lot of damage. This is an EF3 damage, what we call severe damage. And then you start getting into devastating to catastrophic damage whenever you get to EF4. So EF4 is winds approaching 200 miles per hour. And notice this home with an EF4 no longer has a roof and a lot of the walls are missing. And then the one that I showed you from Gerald, Texas, that big 3/4 mile wide tornado, that was called an EF. Well, at the time it was F5. They've changed the scale just a little bit. They added the enhanced part, but it was on a 5. It was the last F5 in Texas's history, thank goodness, and the most farthest southern one that we've ever had in the United States. So incredible catastrophic damage. It just kind of wipes away everything. So that's the enhanced Fujita scale. Again, the ones that we see here in Central Texas most of the time are in those real low end ones, the ones that are gonna just cause minor damage. It's gonna be a headache for your parents to have to call the insurance company and stuff. But again, as long as you're in a safe spot, you're gonna be A-okay. Different parts of the country will deal with those bigger type tornadoes. But we're prepared either way. So as we head towards the end of our presentation, we're going to talk about one more thing, and it's going to be called microburst. Okay, microbursts are strong winds that come out of a thunderstorm. They can do just as much damage as a weak tornado. So before we get into that, there are 3 stages of a thunderstorm. Once you have the moisture, once you have the instability, once you have the lift, you'll have 3 stages of thunderstorm. One is what we call the cumulus stage. This is when it's all upward motion of the atmosphere. Remember the updrafts and downdrafts? It's all updraft. This is when those storms, you'll see them in the spring months, but right now through the early summer, they're all just going up. And you'll watch them and they'll just like grow within seconds, right? So that's the first stage, cumulus stage, all updraft. Mature stage is when you have that upward and downward motion of wind, updrafts and downdrafts. And if this guy starts to tilt a little bit due to wind shear, he's going to be severe, right? And then the last stage is what we call the dissipating stage. This is when it's all just downdraft. It's all just winds going down. It's what we call raining itself out. And it's this stage, you would think this would be the worst stage, right? This is where you can get the hail, and this is where you can get the tornadoes, and this is where you can get just all kinds of devastation. And then you think, oh, this is weakening, we're good. Now you can get some actually intense winds in the dissipating stage of the thunderstorm, what we call micro or macro bursts. So let's kind of show you this animation. Here's kind of our 3D look at Austin. We're in the middle of this thunderstorm. We've had hail, we've had all kinds of stuff, heavy rainfall. There's some of our lightning bolts. And now this thunderstorm is starting to weaken. And you would think weaken means we're good to go. Well, when you're in that dissipating stage, you have this cold air descending very quickly out of the storm, and that allows for an acceleration of the wind. So you can have 60+ mile per hour winds from this collapsing thunderstorm on top of you, what we call straight line winds. And 60+ mile per hour winds can still bring down tree limbs, can still peel off shingles off your home, can do a lot of damage. Again, a microburst can cause just as much damage as a weak tornado. So oftentimes we'll even get reports of, hey, we got a lot of damage here at our house. We think it was a tornado. And then when the National Weather Service meteorologists go and investigate, they notice that all the debris is spread out in one direction. And that's wind going out in one direction. And that's indication of straight line winds or this microburst. Whereas if the debris was there and there and behind me and there, it spread 360 degrees out, that's indication of damage of a tornado. So those are the 2 ways that you can tell after a storm passes and if you have damage, if it was straight line winds or a tornado. If debris or stuff is spread everywhere in all directions, probably a tornado, but if it's all spread out in one direction, it's most likely a microburst or straight line winds. So lastly, this is really good for everyone to remember, kids, adults, everybody, the difference between a watch and a warning. So we'll have some of these in the next couple of months. We're about to get into severe weather season. So you'll see at the bottom of your screen, we're either scrolling it, or if you're watching me do the weather, I'll say a tornado watch is in effect, or a severe thunderstorm watch is in effect, or a flash flood watch. That means that we're just watching out. Doesn't mean anything's happening right now, but that conditions are favorable for potentially some rough weather ahead. So we're on the watch. Nothing's bad happening, but whenever a watch is issued, this is when we want to go over our plan. At school, all right, where are we gonna go? Just in case we get some bad weather, and also at home, where's that safe place? So that's what you want to do for watch. You don't panic in watches. You don't panic at warnings either, because you're going to be prepared. A warning means you got to take action now. Tornado warning, severe thunderstorm warning, flash flood warning. It means it's happening now. Your area is going to be impacted. You got to get to your safe spot. If it's a tornado or severe storm, got to get to your safe spot. If it's flash flooding and you live in an area that's prone to flooding, you got to get to higher ground. So that's the difference between a watch. We're just on the lookout. Could have some rough weather in the hours to come. And then a warning is, hey, it's either happening now or it's headed in your direction. So that does it for Thunder Thursday. I know we covered a lot of stuff, everybody. And I know for maybe some of the little ones, it was kind of going over your head. But these presentations, I wanted them to be geared for everyone. From pre-K, that's what we did Freddie the Frogcaster yesterday, elementary and middle. I was kind of leaning a little bit more junior high, high school today, but I hope everyone enjoyed it. So tomorrow also geared for some of the older kids. That being said, everyone's welcome to hang out, okay? Everyone's welcome, all ages, from 0 to grandpa. And we're going to forecast together. Tomorrow's a little bit different than the last few days. It's not going to be kind of me up here showing you a presentation. It's going to be me sitting down and I'm going to show you everything I look at to put a forecast together. So we're actually going to analyze what's happening in the atmosphere now. It's going to be fun, okay? And we'll do that again next Friday as well. A preview of next week, our last week, week 2. Monday's career day. If you're interested in being a meteorologist, we're going to talk about the different jobs, the equipment that we use, the education that you need to be a meteorologist. We're going to talk about space, the planets, the stars, the sun, meteors on Tuesday. Wednesday, another Reading Wednesday. It's going to be another Freddie the Forecaster book. I looked at it today. It's the hurricane one. It's fun. If you liked yesterday, you're going to love it. I love all of Janice's books. We're going to talk about tropical weather, hurricanes, tropical storms, a week from today, Tropical Thursday, and then we'll forecast together again on Friday. So hopefully you all enjoyed that presentation. It's a little bit longer than the last couple of days, but there was plenty to get to, right? There was a lot to get to, and hopefully you enjoyed it. So I'm going to take a look at some of your questions and stuff. I know some of your parents have other plans for you, so if you've got to go, you do you. And we'll answer just a few questions since I went a little bit over today. So, all right. Gosh, so many comments on YouTube. All right. So a lot of comments. I don't see any questions yet. Okay, Karen, have a good day. Allison's asking about when we'll cover tsunamis. Not in the lesson plan just yet. We haven't got into earthquakes, tsunamis yet. I haven't planned for that just yet. So Becky's asking, how do you predict weather? We're going to do that all tomorrow. It's all tomorrow how we're going to predict that. Stacy's asking, is lightning a shock? Lightning is electricity. And again, you get those different charges in the clouds, the positive and negatives in the clouds. And if it just right connects just right, it's actually electricity. 5 times hotter than the surface of the sun, 50,000 degrees Fahrenheit. Kendra's asking, what is the strongest tornado? I'd have to go do some research on that. The last big strong one in Texas history was the one that we looked at a few minutes ago here just north of us, that F5 tornado in Gerald. But there's been a lot of outbreaks in the 70s that happen in parts of the deep south and mid-south. You can get some really big ones in Oklahoma, El Reno tornadoes. So as far as like what's the worst one, I think there's different criteria for the worst one. Are you talking about lives lost? Are you talking about amount of damage it caused, as far as how much is it going to cost to build everything? So I'd have to look all that up. Oh, hey Amy, Dane's asking about hail. Can it get larger than softball? Yeah, it certainly can. It can get big. It could get really big. Absolutely. The record was just set not long ago. There had been like a long-standing record of like grapefruit. I forget, it was like 4.5-inch diameter hail, but I think the record just got broke not long ago. Yeah, Oswald, I'll have to look that up as well. Mary's asking what tornado did the most damage in US or Texas history. Again, it's all, I apologize, I don't know this stuff off the top of my head. That little trivia stuff, I'd have to go back and do research on it. I can just tell you about the ones that we talked about today. Shelley's asking, how many tornadoes have we had here in Austin? Well, we'll see dozens a year in our area. Typically, they're really small, and they don't last long. They don't cause a whole lot of damage. So if you think about, you get a dozen plus every year, and add that up over 100 years, it's quite a bit. The big tornadoes are rare in our area, but a weak tornado is not. And usually they happen just kind of in rural areas, which is, well, I shouldn't say usually, but at least in our area, we haven't had a whole lot hit super populated areas, thank goodness. And that's basically out of luck. There's no science behind that because tornadoes can happen anywhere. Hussein is saying love space. Yeah, that's going to be Tuesday. Let's see. I'm going to go to YouTube now. Tristan saying, Albert, wait. What you got, Tristan? How big can a cloud get? Again, the clouds go up in the atmosphere 50, 60,000 feet up. The real strong, severe ones, if not a little bit higher than that, they go all the way to the top of the troposphere, or the top layer of the atmosphere that we're at. If you want to know more about the atmosphere, go to Tuesday's lesson when we talk about the atmosphere. Again, I apologize. I get a little sweaty in here because these bright studio lights in this very small room here at my house. So before the newscast, what I've been doing is I crank down the AC. My bill is going to be wacky, but I have to crank down the AC ahead of the newscast to like 69, 70. That way it gets cool in this room. So that's what's going on there. I'm not nervous. I don't have fever, I promise. Spencer's asking, do you think there'll be an EF5 tornado this year? You can't really predict that. I sure hope not. Will we this spring have some big tornadoes in the United States? Absolutely. It unfortunately happens every year. And I think with us being so warm so early, we hit 90 yesterday and the day before, and we'll be close to 90 today. I think for us being so warm so early, we'll probably even have an early severe weather season. Although I've got nothing to tell you about in terms of severe weather between now and the next 7 days. Some thunderstorms possible Friday night and Saturday, maybe again on Monday, but they don't look severe at this point. Yeah, so that's school peeps. That's a good question. Has there been a tornado in Austin that you can remember? Yeah, so going back to our Monday presentation, we talked about one that happened in the early 1920s. It was the first tornado in recorded history, where actually someone recorded it. Certainly not the first tornado ever, but in recorded history, it was May of 1922 that occurred in downtown Austin. It was 2 tornadoes, most likely from the same supercell thunderstorm, same thunderstorm that dropped 2 tornadoes, but that was the first one in recorded history in downtown. Since then, we haven't had anything, and when I talk about downtown, I'm talking like the Capitol and kind of like right in the heart of that downtown area. That's the last time that we had one happen. Now, within central Austin and Travis County, certainly we've had some drop. This past last spring, we had one in Williamson County. Thankfully, it was in a rural area north of Lake Travis, kind of on the Travis and Williamson County line. Tristan's asking, have I ever been in a tornado? No, you're good, Tristan. So I've only seen one tornado in person in my entire life. I was a student at Texas A&M University in College Station. I was a freshman, and I don't know if they're still doing it, but at the time we had a storm chasing group. So a bunch of college kids, chasing storms. And back then the technology was not as good as it was now. I mean, smartphones and stuff just didn't exist back then, because I'm old. So we would have to like stop at like gas stations or like hotels and ask if we could plug into their phone. We were still using what we call dial-up internet, so we'd have to use a phone, like phone jack. You probably don't even have one in your house to download information. But anyway, we were able to see a tornado that day. It was a weak one near Mineral Wells, Texas. The only other person I remember who was on that trip is Justin Horn, who's a meteorologist at KSAT on TV in San Antonio. But that was the first and the only tornado I've ever seen in person. And I don't get the opportunity to chase anymore, because anytime there's bad weather, I'm in the studio. Or here at home now, in the studio, my studio home. Okay, so going back to Facebook, again, parents, if you got other stuff going on, we're coming up on a 50-minute presentation, so you're good. I'm just going to look at a few more questions, since we got still a good audience coming. Julie says, tornado hit the Mueller Airport in the early 80s. Yeah, Julie, that's funny you mentioned that. You jogged my memory. One of the very first stories that I did here at KVUE about 10 years ago was with that tornado. I'd have to go back and relook. Like when you write something 8-10 years ago, it kind of exits your brain, but you're absolutely right. Yep. Got a bunch of Aggies watching. That's good. Sarah's asking early weather season. Yeah, I think an early severe weather season for us, which hopefully that means we end it sooner, right? In the Austin area, April's busy, May gets really busy. So May is historically the wettest and stormiest month out of the entire year. And if we just look at our area, again, if you're in Central Texas, our area, the last 2 weeks of May, for some reason, can be super, super busy, especially around Memorial Day. It doesn't happen every year, but you'll know Memorial Day for being very big. Dorada is asking a question on behalf of Anna, a third grader. Hi, Anna, asking about how planets form. So we'll talk about planets in space on Tuesday. That sound good? So you'll have to tell your mom to set me up again for next Tuesday, or this coming Tuesday. Stacy, I appreciate you watching. Okay, everybody, so that does it for me for day 4 of Albert's Weather Classroom. Hope you enjoyed today's lesson. If you missed Monday, Tuesday, or Wednesday's lesson, I've included the YouTube links there. If you're watching me on Twitter, you can just search KVUE TV on YouTube, and they're there in the live video section. Everyone have a good rest of the day. We'll see you tomorrow for Forecasting Friday. A little different, geared for the older kids. I'm just going to show you everything I look at, and it'll be fun. All right, take it easy, everybody. Have a good rest of the day.